12.4, where it's kind of like a mental break. You're not going to have to do a lot of algebra. Pay attention.
I lost my notes.
You're not going to have to do a lot of algebra today. What you're going to have to do is graph. So you're going to be graphing a compound inequality. You have been graphing inequalities. So an inequality would be something like this. X is bigger than 1. So you would have a circle at 1. It would not be colored in, and you'd go to the right. Okay? That is a single inequality. But now you're going to have a compound. A compound inequality means that you have two inequalities on one graph. Compound, like a compound word, two words, okay? An or situation means that they're separate. So or means separate. Separate. Or means a separate situation. It's like if your family said, you can get a dog or you can go on vacation. You have to choose. You go one way or the other way. You don't get both. Pay attention, some of you are very busy. Okay. Or an or graph will go in opposite directions. So you're going to graph each of them separately. And means you get both. That would be like me saying, you get a dog and you get to go on vacation. So yay you. You get both things. You don't have to choose. You're not going in separate directions. It's connected. It's connected to one. So an and will be connected. Just remember that ends are not separate. Or compound inequalities would be something like this. X is less than a number or X is bigger than a number. You're going separate ways. And means that X is smushed between two numbers. So you have your left number and your right number, and X is in between them. I'll show you an example. We're going to graph the following compound inequalities. So this one I have X is less than -2 or X is bigger than or equal to 0. You just graph them both separate. So if X is less than -2, I would have an open circle at -2. And I'm smaller, so I need to go to the left. My next one, X is bigger than or equal to 0. That means I would be colored in because there's a line under, and I'm bigger than 0, so I go this way. So compound inequalities, graphing them, what they do is go separate directions, or ors. And my choir kiddos, I'm going to keep teaching when you guys decide to leave here in about 3 minutes. You can come grab what you need to grab. But not yet. You don't need to leave yet. Just wait. Okay. Now I have X smushed between two numbers. I have X smushed between two numbers. When X is smushed between two numbers, that's an and. You don't have to be separate. You're together. So you connect them. So I have -8 is my smallest, and I have a line under, so that means it's colored in. So colored in circle at -8. And then I have a normal circle at 4, not colored in because there's no line. So a normal circle at 4, and X is in between them. How you say this is -8 is less than or equal to X, which is less than 4. That's how you say it. -8 less than or equal to X, which is less than 4. It's saying that X is somewhere in between them, and I just connect them like that. Okay? Next one. Are they going to be connected or go separate directions? Separate directions. Yep. And my kiddos that are going to be leaving, this is going to be recorded, so you're going to miss some of this lesson. Just watch it. I'll post it before I leave, maybe. Okay. It's going to be separate directions because it says the word or. That means you can't have both. You can have a dog or go on vacation. You don't get to do both. You pick one. Okay? So here I go. X is less than or equal to 0. So I'm going to have a colored in circle at 0 going left. Bigger than or equal to 9. Both of them are colored in. 9 bigger. So separate directions. They look kind of cool, huh? The next one, are they going in separate directions or connected? Connected, yep. So I have -6 is less than X. -6 is less than X, which is less than 3. So what I'm doing here, I should be the only voice. What I'm doing here, I'm smushed in between. So I am going to plot those two numbers, -6 and 3, and be in between them. So -6, not colored in, there's no line. Okay. This transition doesn't have to be chaotic. And then my circle is at 3. Stop. And now I'm connecting them. So I'm smushed in between. Francis, shut my door, please. Or my kiddos that are leaving, please make sure that my door gets shut. Nice, please. Next page. Now we're going to write from a graph. So, learning target, you have 4 of them today. Learning target number 1 is to graph. So I'm going to give you a compound inequality, which means more than 1, and you graph it. Learning target, pay attention to me. Learning target number 2 is I'm going to give you a graph. You got to write the compound. Okay, so here we go. If it's an OR graph, it goes separate directions, and this is how you do it. X is less than the left number or bigger than the right number. And don't forget to color in if you need to. You might need the line under. If it's an AND graph, you do the left number less than, X in the middle, less than the right number. Okay, so when I look at this first one, my left number is a -6. So I'd say X is less than or equal, because it's colored in, -6. Or, and now it's got to be bigger, because it's going the opposite way. Make sure you're writing this down. X is bigger than or equal, because it's colored in, and it's the number 0. So it's not too shabby. Today's learning target's pretty chill. Okay, another OR because it's going in separate directions. So this one I have X is less than, you always do the less than first. X is less than -1, and it's not colored in, so don't make a line under it. Or, you can be bigger. X is bigger than the right number, and it looks colored in, so I'm going to make a line under it. If you don't have a line, don't rush this, even though it's faster than what you've been doing this week. Don't rush it, okay? Because you might forget a line and you won't get the problem right. No mistake. So X is bigger than or equal to 8. Moving on. Now this one looks kind of weird. It is an OR graph. It means I can be any number in the whole wide world except for this middle number, or this number it's at. So you would say X is less than, it's not colored in. X is less than is at 1. Or it's also at 1 again. 1 is the only number it's got. X is bigger than 1. Which just means it can be anything in the world besides 1. Okay, and graphs are smushed in between. So and graphs are always blank less than X less than blank. So you always have number less X less number. Okay. So this one is colored in. So my left number is -6 less than colored in. Make a line. X, which is smaller than colored in. Make a line. My big number is 9. So it's smushed between. If it's smushed between, you make a between. My next one, I'm smushed between -10 and 2. So I would say -10, it's not colored in, so just a normal less, then X, and then X is not big, it's less than colored in or equal to 2. So it's smushed between. And lastly, we have X, and oh, just kidding, I almost made an OR graph. But I can fix it, look at what I can do. There we go. Smush it to the middle. Okay, but so 0, colored in though, and then 8, and that is also colored in. Okay, I'm gonna bump it up 1 level, a very fancy level. What you're gonna have to do is change, like we're not gonna go in sequence to how your notes are in order, so what you need to do is find interval notation. I think you have to Just flip a page if I remember right. Yeah, I think you just need to flip a page. Not that one, it's right here. Okay, don't be sidebarred. No combos. Okay, so now that we're on to learning target number 3. Did you hear me? Look at me. We're on learning target number 3. Number 3 is this fancy thing called interval notation, or they say step builder. Interval notation has infinity involved, so I want you to write that. And I was going to do this on Thursday, but today's lesson obviously is super chill, and so is interval notation. So I decided to combine them. Okay, so parentheses, you'll figure out how to do infinity at some point. So parentheses means a number is not included. A bracket means it's included. For example, if I said -1 to infinity, you don't color them in. So this would be a graph that would be at -1, not colored in, and I go all the way to infinity. A bracket means you color it in. It would be like this. Bracket -1, comma, go to infinity, which just means go forever. That's all it means. You've been doing that the whole time. Now you're just writing it. And you can't color infinity in because it truly doesn't exist. So you have to use a parenthesis for infinity. And so what that one means is this. -1, circle, colored in, to infinity. Okay. Here I go. This is an and. The only ones that go to infinity are your ors. So I want you to write that down. Ors have infinities. Can you guys? What up? It's no big deal. Figure it out. Ors have infinity. Ands only have numbers. So ands are just numbers. Okay? And infinity, you can never color it in. There's no way in heck. So it's always got to be a parenthesis. And if you think about brackets, so brackets have that solid line. That's like the solid line under the inequality symbol that we've been doing. Okay? Okay, so this one is an and graph. I'm smushed between two numbers. Pay attention. You have never seen anything like this. It's weird. So I'm smushed between two numbers. So what I'm going to do, you don't have x's, okay? So interval notation, there's no x's involved. You just have, the x's are the brackets and parentheses. So I would be parenthesis -4 because it's not colored in, comma, and then I go to what I go to. I go to +4. So +4 bracket. That's how you write this. So the difference between this and a point is brackets.
Wait, why is it
a bracket? Because it's colored in. Brackets do colored in. It's like a solid.
There's going to be a bracket on the other side?
No, because that's not colored in there, so it's a parenthesis. Okay, my next one is also an and graph. Why don't I have any ors? My next one is also an and graph, so you only have numbers. Ors are infinities. Ors are infinities. Because that is not going to infinity, positive or negative. It's just smushed between those little numbers. I'm colored in. So bracket, my small number 0, go to my big number 3, colored in, so another bracket.
That's great.
I love it. I kind of want to do one. You're going to make one with me in a second. Okay, another one that has no infinity. This is an and graph. Ands do not have infinities. So I'm not colored in, so parenthesis, small number, -6, comma, to my biggest number, -3, and don't be colored in. So it looks like a point, but it's really an interval. It's the interval of it. Okay, real quick, I want to do one where, we have infinities. So make a number line, just let's go 0, 1, 2, 3, 1, 2, -3. Okay? So you have room on the bottom. You need to know how to handle infinities though. You don't have any infinities in those. Infinities are only ors. If you have an and, you better not have infinities in it. Okay, so I'm going to go ahead and go. Wait, not right now. Shh. So I'm going to go color in, go to that. Not colored in, go to that. Okay, now I have an or. Because I'm going in two separate directions, so it's an or. I can't be both. You're one or the other. I always tell my students, especially my 8th graders when we do this, I say go left to right. So now look, the smallest number you have, if you go left to right, and that's what we've been doing, smallest -6 to biggest -3. But I don't have a smallest, but I do. My smallest, not colored in, parenthesis, is negative infinity.
Wait,
That's my smallest number. It's not, you can't color infinity in. It will be colored in a second. Then I go from negative infinity all the way to this number. And this number is -1 colored in, so bracket. Or, because I'm going two separate ways, just go left to right. So I went negative infinity, -1. I keep going. Now I'm at 2, but not colored in. 2, and what's your biggest number? Infinity. Yeah, 2 goes to infinity, and you can't color it in. Okay. Do you have where you graph with this fancy stuff or no? Okay. Okay. I want you to just think, I'm going to make this, and someone's going to come up and graph it. We're going to be recorded for a little bit. 1 and 2. Well, all right. Fine, I'll graph the first couple. Actually, I want to lock this, so I don't have to keep remaking it. So I'm going to lock this and allow it to move. Lock, allow, move. Okay, so you've had 3 learning targets. Learning target number 1, did we graph? Learning target number 1, you graphed a normal inequality compound. So you did an or you did an and graph. Learning target number 2, you wrote a compound. That's when you have x's. So like x is less than 5 or x bigger than 10. Or smush between. Learning target number 3 is this fancy interval stuff. Learning target number 3 has infinities. Okay, so ors have infinities. Ands are just like, it looks almost like a point. So ands are points or brackets. And learning target number 4 would be to graph with this fancy stuff. Graph with learning target number 3. Okay, so here I go. Okay. I should have 2 circles. You should always have 2 circles on your graph. What number should my first circle be at? 1. Colored in or not? Colored in. In which direction should I go?
Left.
To the left. I'm going to negative infinity. So go all the way to negative infinity. And where's my second circle go? 2. And what direction does it go? Right. So I'm going to positive infinity. Exactly. Okay, let's do another one like this. Okay. Okay. Let's go like this. Bracket -2, comma 3 parentheses. Good. I should have 2 circles. And then you gotta tell me, are they connect, or is this an and or an or graph? And. I'm smush. I have no infinity, so I'm an and. Okay, where's my first circle? Colored in or not? Color in, -2. And then, where's my second circle?
3.
And colored in or not? Go in separate ways or smush them together? Smush them together, like that. Okay? Do you feel like you can handle these 4 learning targets?
Oh, yeah.
Yes, ma'am.